In this video, we're going to look at finding a Taylor series through the definition of the Taylor series. So the function that we're interested in is sine of x. We want this centered at a equal to pi over 2, and we're asked to find the Taylor series and find its radius of convergence. So again, looking at the definition, we need to take successive derivatives of the function, plug in the center, which is pi over 2 in this case, and see if we can get a pattern for the coefficients. Well, successive derivatives are just alternating back and forth between sine and cosine with some negatives thrown in, right? The function is sine of x, its first derivative is cosine. Second derivative is negative sine. Third derivative is negative cosine. Fourth derivative is sine, and then we repeat. Which means our coefficients, after we plug in pi over 2, will also repeat. So plugging in pi over 2 into the original function, we get 1. First derivative, we get 0. Second derivative, we get negative 1. Third derivative, we get 0. Fourth derivative, we get 1. And so it'll continue in this pattern. The signs will alternate on the even terms, even derivatives, second, fourth, sixth, and so on. And it will alternate between 1 and negative 1. So it's equal to 1 at the multiple of 4. It's equal to negative 1 at 2 more than the multiples of 4, and it's 0 otherwise. So the way we'll capture this in the Taylor series is, well, only the even term survives, so we want only even ends. So if we've got our series going from n equals 0 to infinity, we'll use 2n as our index in our denominator for the n factorial and our exponent for the x minus pi over 2. This will capture the fact that we only have even terms that are non-zero. All right, we want it to alternate back and forth. The 0 power should have a positive 1. The second power should have a negative 1. Fourth power should have a positive 1. Sixth power should have a negative 1. So when we put in 0, we better get 1. When we put in 1, we better get negative 1. When we put in 2, we better get 1. So we need an nth power here, not an n plus 1. All right, so this is our Taylor series. Now we're being asked to find the radius of convergence. Ratio test works here. Again, ratio of our consecutive terms in here, plugging in n plus 1 for n on top, taking the absolute value, and then taking the limit. Put our terms that go together. The negative 1s will just go away because we're doing absolute value. We'll have 2n factorial over 2 times the quantity n plus 1 factorial. That's the same thing as 2n plus 2 times 2n plus 1 times 2n factorial. And this 2n factorial will flip to the top when we multiply by the reciprocal. X minus 2 to the 2n plus 2 is what you get here when you distribute. So you'll have 2n plus 2 and a 2n as our exponents. When we subtract, we'll just get 2. So we'll get an x minus pi over 2 squared there. Notice that the 2n factorials cancel each other out, so we get the limit as n goes to infinity of 1 over 2n plus 2 times 2n plus 1 times the quantity x minus pi over 2 squared. We're looking for what this limit does for a fixed x. It can be whatever you want, but it's going to be fixed once you plug it in. Once it's fixed, the denominator here gets arbitrarily large, so the fraction will get arbitrarily small. So that means the limit is 0 no matter what we plug in for x. So that means our radius of convergence is infinity.